In the vast, dark theater of space, our small blue planet has always looked up at its silent, glowing neighbor, the moon. For all of human history, it was a distant dream, a symbol of the unattainable, a light in the night sky. But on a very special day in the summer of 1969, something incredible happened. Humanity reached out and touched that dream. The Apollo 11 mission carried the first humans to the surface of another world. This was not just a journey of a few brave astronauts. It was a journey for every person on Earth. It showed us what we could achieve when we combined our courage, our intelligence, and our desire to explore the unknown. The moon landing was more than just a scientific achievement. It was a moment that brought the entire world together. People from different countries, speaking different languages, all stopped to watch. They held their breath as they listened to the crackling voices coming from 250,000 miles away. For a brief time, our differences seemed small compared to this monumental human accomplishment. The first steps on the moon were a powerful message. They told us that the universe was within our reach. They told us that if we could walk on the moon, perhaps we could solve the great problems we faced here on Earth. This event, watched by over 500 million people, became a defining moment for our species. It was a testament to human ingenuity and our unyielding curiosity. The mission represented the pinnacle of a decade of intense effort, a national goal set by a president who dared to dream big. The astronauts, Neil Armstrong, Buzz Aldrin, and Michael Collins, became heroes not just for their nation, but for all humankind. Their bravery in strapping themselves to a massive rocket and venturing into the void of space inspired generations to look up at the stars and wonder what else is out there, waiting to be discovered. So let's journey back to that time. Let's explore why we went to the moon and how we did it. We will look at the challenges, the triumphs, and the enduring legacy of this incredible adventure. The story of Apollo 11 is not just history. It is a reminder of our potential. It is a story that continues to inspire us to push the boundaries of what is possible, to ask big questions, and to boldly go where no one has gone before. It is the story of how we took our first tentative step into the larger cosmos, forever changing our perspective of our place within it. To understand why we went to the moon, we must look at the world in the 1950s and 60s. This was a time of great tension, known as the Cold War. Two powerful superpowers, the United States and the Soviet Union, were competing for influence around the globe. They had different ideas about how society should be organized. This competition was not just political or military. It extended into science, culture, and even space. This intense rivalry gave birth to something amazing: the space race. It was a peaceful, yet powerful competition to see who could achieve supremacy in the cosmos first. The race began in 1957, when the Soviet Union launched Sputnik 1. It was the first artificial satellite to orbit the Earth. This small, beeping metal sphere was a shock to the United States. It showed that the Soviets had powerful rocket technology. The Americans worried they were falling behind in science and engineering. The Soviet Union followed this success by sending the first animal into orbit, and then, in 1961, the first human, Yuri Gagarin. Each Soviet achievement added more pressure. The United States knew it had to do something spectacular to catch up and demonstrate its own technological strength. In response, President John F. Kennedy made a bold declaration in 1961. He stood before the American people and set a new, audacious goal. He said that America should commit itself to landing a man on the moon and returning him safely to the Earth before the end of the decade. This was an incredible challenge. At the time, the United States had only sent one astronaut into space for a short 15-minute flight. No one knew how to build a rocket powerful enough, how to navigate to the moon, or how to land on its surface. It was a leap of faith in the power of science and human will. The space race became a central part of the Cold War. It was a way for each country to prove that its system was superior without fighting a direct war. Every successful launch was celebrated as a national victory. Every failure was a public setback. The goal of reaching the moon pushed scientists and engineers to work faster and smarter than ever before. It fueled a massive investment in education, research, and technology. The race was not just about planting a flag, it was about inspiring a nation and showing the world what a free and democratic society could accomplish. To achieve President Kennedy's ambitious goal, NASA created the Apollo program. This was a massive undertaking, the largest and most complex technological project in human history up to that point. It required the work of over 400,000 people, from brilliant scientists and engineers to skilled factory workers and technicians. The program's centerpiece was the Saturn V rocket. This was not just any rocket, it was a true giant. Standing taller than a 36-story building, it remains the most powerful rocket ever successfully flown. Its job was to lift the Apollo spacecraft and its crew out of Earth's gravity and send them on their way to the moon. The Apollo spacecraft itself was a marvel of engineering, composed of three main parts. The command module, nicknamed Columbia for Apollo 11, was the crew's living quarters and command center for the journey. It was the only part that would return to Earth. Attached to it was the service module, which carried the main engine, oxygen, water, and power supplies. The third part was the lunar module, called Eagle. This was the small, spider-like craft designed specifically to separate from the main ship, land on the moon's surface, and then launch back up to rejoin the command module in lunar orbit. However, the path to the moon was not without tragedy. In January 1967, during a routine launch rehearsal for the very first Apollo mission, a fire broke out inside the command module. The three astronauts inside, Gus Grissom, Ed White, and Roger Chaffee, lost their lives. This disaster, known as Apollo 1, was a terrible shock. It forced NASA to stop and re-examine everything. They made hundreds of safety improvements to the spacecraft and the procedures. The tragedy reminded everyone of the incredible dangers involved in space travel, but it also strengthened their resolve to succeed in honor of the fallen crew. After the Apollo 1 fire, NASA moved forward with caution and determination. They conducted a series of unmanned and manned test flights to ensure every system worked perfectly. Apollo 7 tested the command module in Earth orbit. Apollo 8 took the first humans on a trip around the moon, allowing them to see the far side with their own eyes. Apollo 9 tested the lunar module in the safety of Earth orbit, practicing the docking and undocking maneuvers. Finally, Apollo 10 was a full dress rehearsal, flying all the way to the moon and descending to within 9 miles of the surface before returning. With each successful mission, confidence grew. The stage was set for Apollo 11. On July 16, 1969, the world watched as Apollo 11 stood ready on the launch pad. Inside the tiny capsule at the top of the giant Saturn V rocket were three astronauts, Commander Neil Armstrong, Lunar Module Pilot Buzz Aldrin, and Command Module Pilot Michael Collins. The countdown reached 0, and the 5 massive engines of the first stage ignited with a deafening roar. The rocket trembled, slowly lifted off the ground, and then climbed into the bright blue Florida sky, leaving a trail of fire and smoke. For the million people watching from the ground, it was a sight of awesome power, a truly earth-shaking event that marked the beginning of this historic journey. The trip to the moon took about 3 days. For most of this time, the astronauts traveled through the quiet emptiness of space. Inside their small spacecraft, they checked their systems, navigated their course, and looked out the window at the incredible view of Earth getting smaller and smaller behind them. Michael Collins, who would orbit the moon alone while his crewmates landed, later described Earth as a small, beautiful jewel floating in the blackness. As they got closer, the moon grew larger in their window, transforming from a distant light into a vast, cratered world. The time for the most critical part of the mission was approaching. Once they reached lunar orbit, Armstrong and Aldrin moved from the command module into the lunar module, the Eagle. They separated from Columbia, leaving Michael Collins to continue circling the moon. The descent to the surface was the most dangerous part of the flight. As the Eagle headed down, Armstrong noticed they were going to land in a rocky crater filled with large boulders. He had to take manual control of the lander, flying it like a helicopter to find a safe, flat spot. With only seconds of fuel left, he gently set the craft down in a region called the Sea of Tranquility. His first words back to mission control were calm and clear. "Houston, Tranquility Base here. The Eagle has landed." On Earth, a collective sigh of relief and a wave of celebration swept through mission control in Houston and across the world. They had made it. Humans were now sitting on the surface of another celestial body for the very first time. For several hours, Armstrong and Aldrin prepared for their moonwalk, checking their suits and equipment. Meanwhile, Michael Collins orbited silently above them, a lonely sentinel 60 miles high. He was completely cut off from radio contact with Earth each time he passed behind the moon. He was the most isolated human being in history, but he was a vital part of the team, waiting for his crewmates to complete their work and return. A few hours after landing, the hatch of the lunar module opened. Neil Armstrong carefully made his way down the ladder. As he stepped off the final rung and his boot pressed into the fine, powdery lunar soil, he spoke the famous words that would be remembered forever. That's one small step for a man, one giant leap for mankind. For the first time, a human being was standing on a world that was not the Earth. Buzz Aldrin joined him on the surface about 20 minutes later. He looked around at the stark, beautiful landscape, which he described as magnificent desolation. The two astronauts began their historic moonwalk. The astronauts had many important tasks to complete in a short amount of time. Their main job was to be scientists. They collected samples of moon rocks and soil, carefully placing them in sealed boxes to bring back to Earth. These samples were incredibly valuable, as they would help scientists understand the moon's origin and history. They also set up several scientific experiments. One was a seismometer to detect moonquakes. Another was an experiment to study the solar wind, a stream of particles from the sun. These experiments would continue sending data back to Earth long after the astronauts had left. Beyond the science, the astronauts also performed symbolic acts. They planted an American flag on the lunar surface, a symbol of the national effort that made the mission possible. Because there is no wind on the moon, the flag had a horizontal rod to keep it unfurled. They also took a phone call from the President of the United States, Richard Nixon, who spoke to them from the White House. The astronauts left behind a plaque on the leg of the lunar module. It has a picture of the Earth's hemispheres and a message that reads, "Here men from the planet Earth first set foot upon the moon, July 1969. AD, we came in peace for all mankind." After about 2.5 hours outside, Armstrong and Aldrin climbed back into the safety of the Eagle. They had completed all their tasks. They had walked, hopped, and bounced around in the moon's low gravity, which is only 1/6 as strong as Earth's. They left behind their footprints, the scientific instruments, the flag, and the plaque. They also left behind medals honoring the astronauts who had died in the Apollo 1 fire, and Soviet cosmonauts who had also perished in the pursuit of space exploration. Their work on the surface was done, and it was time to prepare for the journey home. How do we know the moon landing really happened? Well, the evidence is overwhelming and comes from so many different sources. First, there are the hundreds of pounds of moon rocks. Armstrong and Aldrin brought back over 47 pounds of lunar material from Apollo 11, and later Apollo missions brought back even more. These rocks are completely unique. They have no water in their chemical structure. They show signs of being hit by micrometeorites in a vacuum, and their geologic age is far older than most rocks on Earth. Thousands of scientists all over the world have studied these rocks for decades, and they all confirm they could only have come from the moon. Second, there is the photographic and video evidence. The astronauts took hundreds of photos and recorded television footage on the lunar surface. These images are iconic and have been studied in great detail. We can see the astronauts, the lunar module, the American flag, and the vast, empty landscape of the moon. While some people question details in these photos, every question has a logical, scientific explanation that fits with the conditions on the moon. Furthermore, Michael Collins was taking photos from the command module in orbit, capturing images of the Eagle both before it landed and after it took off from the surface to rejoin him. Third, the astronauts left behind special mirrors on the moon's surface called retroreflectors. These aren't ordinary mirrors. They're designed to reflect a beam of light directly back to its source. For over 50 years, observatories on Earth, like the McDonald Observatory in Texas, have been able to shoot powerful lasers at these reflectors. They can then measure the time it takes for the light to travel to the moon and bounce back. This experiment not only proves that we were there to place the mirrors, but it has also allowed us to measure the distance to the moon with incredible precision, down to just a few centimeters. Finally, there were hundreds of thousands of witnesses. This includes the thousands of scientists and engineers who worked on the project, the mission controllers who spoke to the astronauts, and the journalists who covered the event. The Soviet Union, America's biggest competitor, was tracking the Apollo 11 spacecraft with its own sophisticated equipment. If the mission had been faked, the Soviets would have been the first to expose it to the world. Instead, they acknowledged the American achievement. All of these independent sources together create a mountain of evidence that makes the moon landing one of the most well-documented events in human history. Despite the vast amount of evidence, some people believe the moon landings were faked. These are often called conspiracy theories. These ideas can be interesting to think about, but honestly they fall apart when we look at the science. Let's explore a few of the most common claims in a respectful way. One popular myth asks why there are no stars visible in the photos taken on the moon. The answer is simple photography. The lunar surface was brightly lit by the sun, and so were the astronauts in their white suits. The camera settings, its shutter speed and aperture, had to be adjusted for these bright objects, which made the faint light from distant stars just too dim to be captured. Another common question is about the American flag. People ask, why does the flag look like it's waving in the wind if there's no air on the moon? This is a great observation. The flag was held up by a horizontal pole at the top, but the astronauts had trouble extending it all the way. This created a ripple or a fold in the fabric. When the astronauts planted the flagpole into the lunar soil, they twisted it back and forth, which made the flag move. In the vacuum of space, with no air resistance to slow it down, the flag continued to sway for a bit before stopping. It was not waving in the wind, it was just moving from being handled. Some people also point to the shadows in the photos. They claim that because the shadows are not all parallel, there must have been multiple light sources, like studio lights. However, the sun was the only light source. The reason shadows can look strange is because of perspective. Think about how railway tracks seem to come together in the distance. The same effect happens with shadows on a wide, uneven landscape. The hilly, cratered surface of the moon makes the shadows fall at different angles, creating an optical illusion. Scientists have been able to recreate these exact shadow effects using models of the lunar terrain and a single light source. Finally, some wonder why we haven't gone back recently. The main reason is cost and political will. The Apollo program was incredibly expensive, driven by the goal of winning the space race. Once that goal was achieved, the political motivation and public funding decreased. However, humanity is planning to return. NASA's Artemis program aims to send astronauts back to the moon, this time to build a sustainable presence and prepare for future missions to Mars. Exploring space is hard and expensive, but the desire to go back is strong. The science behind the original landing is solid, and it paved the way for these future adventures. The impact of the Apollo program went far beyond just putting footprints on the moon. The push to solve the immense technological challenges of space travel led to countless inventions that have changed our daily lives here on Earth. This is often called the Apollo effect. To make the spacecraft as light and powerful as possible, engineers had to invent new ways of making electronics smaller and more efficient. This work directly led to the development of microchips and integrated circuits, which are the foundation of every modern computer, smartphone, and digital device we use today. The need to keep astronauts safe and healthy in a hostile environment also spurred medical innovations. NASA developed new techniques for monitoring a patient's vital signs remotely, technology that is now used in hospitals and intensive care units around the world. To create nutritious food for long space journeys, new methods of freeze-drying were perfected, a process now used for many packaged foods. Even things like fire-resistant materials used by firefighters, cordless power tools, and memory foam mattresses have their roots in technology originally developed for the space program. Scientifically, the knowledge we gained was revolutionary. The moon rocks brought back by the Apollo missions completely changed our understanding of the moon and the early solar system. By studying these rocks, scientists confirmed the giant impact hypothesis, the theory that the moon was formed from debris left over after a massive object, about the size of Mars, collided with the early Earth. This event was one of the most significant in our planet's history, and the evidence was locked away in those lunar samples until we went there to get them. The moon became our celestial laboratory. Culturally, Apollo 11 had a profound effect on how we see our own planet. The photograph of Earth rising over the lunar horizon, known as Earthrise, taken during the Apollo 8 mission, became an icon. For the first time, people saw our world not as a collection of separate countries on a map, but as a single, beautiful and fragile planet floating alone in the vastness of space. This new perspective, often called the overview effect, helped inspire the environmental movement of the 1970s. It gave us a sense of shared identity as inhabitants of planet Earth and a shared responsibility to protect our only home. The legacy of Apollo 11 is not just a story in a history book, it is a living inspiration that continues to shape our dreams for the future. The mission proved that humanity can achieve seemingly impossible goals when we work together with a clear and ambitious vision. It taught us that our greatest limitations are often the ones we place on ourselves. Every time we look up at the moon, we are reminded that we have walked there. This knowledge fills us with a sense of pride and wonder, and it fuels our curiosity to explore even further, to ask what other worlds are waiting for us among the stars. The spirit of Apollo lives on in every space mission that launches today. It is present in the robotic rovers exploring the surface of Mars, searching for signs of past life. It is there in the powerful telescopes, like the Hubble and the James Webb, that are peering into the distant universe, showing us galaxies that formed shortly after the Big Bang. It is in the international cooperation aboard the International Space Station, where astronauts from many nations live and work together for the advancement of science. The giant leap of 1969 was the first step in a much longer journey of cosmic discovery. Now, a new generation is preparing to follow in the footsteps of Armstrong and Aldrin. Programs like NASA's Artemis are aiming to return humans to the moon, not just for a short visit, but to stay. The goal is to build a permanent base, a lunar outpost where we can learn to live and work on another world. The moon can serve as a training ground and a stepping stone for the next great adventure, a human mission to Mars. The challenges are still immense, but the lessons learned from Apollo give us the confidence and the roadmap to face them. The story of Apollo 11 is ultimately a story of hope. It reminds us that we are a species of explorers, driven by an innate need to see what is over the next hill, or in this case, the next world. The universe is vast and full of mysteries, and we have only just begun to explore it. As we continue to push the boundaries of science and technology, we honor the legacy of all who came before. We carry forward their courage and their vision. The future of humanity is not just on Earth, it is in the cosmos. And it all started with one small step.